Good morning everyone. So for today class physics, so we're gonna continue with the last topic, hydraulics. Okay, this is the diagram. Okay, equipment. Okay, where normally the mechanic will use to lift up the car when they're changing the tire. Okay, we call this as a hydraulic car jack. Okay, jack, J-A-C-K. Okay, so how this thing works? Okay, as you can see, okay, this is how behind this theory. Okay, of how these equipments function. Okay, let us move to the next slide. Okay, before that, let me change this. Okay, let's see the Pascal principle. Pascal principle. Okay, so he say that states that pressure applied to an enclosed liquid is transmitted equally to every part of the liquid. Okay, let's say when you squeeze the toothpaste. Okay, when you squeeze the toothpaste, you will produce a pressure inside the toothpaste, right? So when you squeeze here, so the toothpaste that come out here and comes out from here, okay, they will be equal. The amount that comes out will be equal because here it say the pressure applied to an enclosed liquid is transmitted equally. So anything that comes out from here and here will be the same. Okay, now move on to the next slide again. Okay, something like this. Okay, where you push this. Okay, we call it as a piston. Okay, piston, this blue thing. Okay, when you push, by pushing the piston, you are giving the force per unit area. Okay, which means the pressure. Okay, so if the liquid is trapped in a container and pressure is applied, something like this, the liquid is trapped, okay, cannot come out. Okay, and pressure is applied. Okay, this pressure will be transmitted equally in all directions. Okay, when you push the piston, so you will apply a pressure. Okay, this pressure will be inside here will be the same value. Okay, that is what it means by here. Okay, so according to Pascal principle, all the water that moves out from the holes, these holes, okay, receive the same pressure. Okay, remember pressure will be transmitted equally in all directions. Okay, inside here. Okay, all direction which means up, okay, left, right, down, okay, or all direction, right? Okay, now we go back to this hydraulic system. Okay, so in Pascal principle, okay, it's widely used in a hydraulic system. Okay, where you have the force. F1 means the force. Okay, F2 also force. This is input force. Input force means force that you apply. Okay, F2 is called output force, where output force is the force that produced from the F1. Okay, A1 will be the area, A2 will be the area over here. Okay, distance 1, V1, V2 is show you that how long the piston move. Okay, from here to here. Okay, how many centimeter or meter, okay, the piston moves down or piston move up. Okay, inside here you will have a liquid, which is the fluid. Okay, normally we'll use this formula. Okay, output force divided by input force. Okay, F2 divided by F1. Okay, and then output piston area divided by input piston area. A2 divided by A1. Please remember the formula. Okay, and always put F1 here. Okay, and A1 and F2 and A2 here. Okay, okay, again. So they say that hydraulic system acts as a force multiplier. Okay, they multiply the input force by a certain factor to get a larger output force. So which means that if you apply force here, let's say the magnitude is 10 Newton. So the force that comes out here will be double, so which means 20 Newton. Okay, force that comes out from here, 20 Newton. That's why they say hydraulic system acts as a force multiplier. Okay, so a small input force is applied to a small piston, this area, okay, resulting in a large output force, this one. Okay, however, the principle of conservation of energy, okay, still apply in a hydraulic press. Okay, hydraulic press. So assuming no friction, so the work done by a smaller force, this one, over a longer distance dx on piston 1 will be equal to the work done by a larger Fy, okay, over a shorter distance dy on piston 2. Okay, notice that this is the formula for work done, force times distance. Okay, so this over here and over here, okay, they should be the same. Okay, fx times dx, okay, which is the work done over here, fy times dy, okay, this is the area, this is the path, so they should be equal, right? Okay, let's see. There is a question something like this. Okay, what will happen to the hydraulic system if the air bubbles exist in a brake fluid? Okay, so hydraulic system must not contain any air bubbles, okay, in any position of its hydraulic fluid system. Why? Okay, this will reduce the efficiency of the system as part of the applied force will be used up to compress the air bubbles. Okay, which means it will disturb the efficiency of the system. Okay, so this is the reason why, okay, the hydraulic system must not contain any air bubbles. Okay, another one here, why oil is preferred to be used in hydraulic system? Okay, why? Okay, because oil, it helps to reduce friction and also prevent rusting. Okay, let's see some example here. Okay, this is the hydraulic system. Okay, let's say driver press down on a jack. We call this a jack handle here, and then this jack handle, okay, and then this area will lift it, okay, the car. Okay, it will lift the car, okay, by the jack here. Let's see the diagram here, something like this. Okay, this person, okay, so you can put here as a F1 and A1. This will be the F2 and A2. Okay, so the force will be here will be smaller, and force that comes up from here will be bigger. So that's why this equipment can lift the car, can make the car goes up. Okay, so let's see an example calculation here. Okay, let's say the force here will be 10 Newton. Okay, and then here will be the area, this area, okay, will be 10 cm square. Okay, usually you have to convert the unit into meter square. Okay, change to meter. Okay, but in this question, just follow what is provided. Okay, let's say the, okay, you know that this is a pressure formula, general formula pressure. Okay, force divided by area. So 10 divided by 10, it will give you 1. Okay, so the pressure 1 Newton, okay, per cm square, okay, will be same anywhere in the system. Okay, which means that here, or here, they all will be have the same value. Okay, remember that same. Okay, so let's say this area for the second part, okay, which is a large piston, the area will be 40 cm square, sorry. Okay, and then you have to times the force. Okay, when you want to find the force here, okay, as you know that the pressure is always the same, okay, every part. So that's why if you want to find the force here, so you just take the pressure, this formula of the pressure, okay, and then you try to let's say try to adjust. Okay, so you will get the force equal to pressure times area. The area is given, pressure is also given. Okay, so the pressure, so the answer will be 40 Newton. So the F2, or you can say the output force, will be equal to 40 Newton. Okay, as you can see, right here will be 10 Newton, here will be more bigger the force. Okay, always like that. Okay, here smaller, here will be bigger. Okay, so using a hydraulic jack, a small force can be multiplied, okay, to lift a heavy car. Okay, so that's why he gave just now the diagram where the person lift, okay, use the equipment, okay, lift and to lift the car. So that's why, because of the big force, okay, bigger force, okay, so that's why you can lift the car. Okay, so application of Pascal principle in everyday life. So you normally use the hydraulic jack, you can use to lift and carry heavy loads. When a small input force is applied, okay, you will get is a large output force is produced. Okay, or you can use a hydraulic brake. Okay, hydraulic brake. So car brake use liquid pressure to transmit the pressure. Okay, apply at the brake pedal to the brakes of the other wheels simultaneously. Okay, so this is another, okay, application for hydraulic system. Okay, right. So we already finished everything, the objective here. Okay, for this chapter. Okay, where you already learn about the pressure formula, the general one, and you also already learned the liquid Okay, the liquid pressure. Also, you also already learned the manometer and also the barometer. Okay, and the last one will be the hydraulic system. Okay, so please, okay, do your revision for this topic. Okay. Okay, so thank you guys. Okay, thank you for watching and listening to this video.